Hey there, students. Today I'm going to show you how to solve polynomial inequalities easily using the wavy curve method. If you're tackling polynomial inequalities like px0 or px0, this method is a game changer. First, let's understand the wavy curve method helps you find out where a polynomial expression is positive or negative on the real number line. Next up, you need to find the roots of the polynomial. These roots divide the number line into different intervals. By testing points within these intervals, you can figure out where the polynomial changes its sign. Now here's the fun part. The sign of a polynomial changes at its roots if they have odd multiplicity. For even multiplicity, the sign stays the same. Time. 1. Factorize the polynomial completely. 1. Identify the roots where the polynomial equals 0. 1. Plot these roots on a number line. 1. Determine the sign of the polynomial in each interval created by these roots, considering the multiplicity of each root. Here's the sign alternates between positive and negative as you cross each root with odd multiplicity. With even multiplicity, the sign remains the same. After you've sorted out the signs in each interval, solving the inequality is a breeze. Just pick the intervals that satisfy the given condition. Let's check and take 2x equals sign x1, x2 squared, x3. The roots are x equals sign 1, minus 2, 3. These roots split the number line into intervals. Infinity minus 2, minus 2, 1, 1, 3, 3, infinity. By testing points within each interval and considering the multiplicity of the roots, you can see the sign changes and solve the inequality. And that's it. The wavy curve method is an efficient and systematic way to tackle polynomial inequalities. Master this method and you'll be breezing through algebra in no time. Thanks for watching.